Alright, so we're going to build a new knob for the Anytone 868878. This is meant more as a walkthrough rather than a tutorial. So I might be skipping some steps like showing you how to measure things, but I'm pretty sure everyone can figure that out. But get a good caliper. You don't have to spend a ridiculous amount of money on it. A $30, $40 one from Amazon will be just fine, given that most 3D printers aren't that accurate. And in fact, you're probably going to need to make some adjustments to your model to accommodate for the inaccuracies of the 3D print later on. So be prepared to print multiple copies once you actually get there. So anyway, take the measurements, write everything down, and we'll see you over in Fusion 360. So now that we're in Fusion 360, we're going to go ahead and create a sketch and copy all the measurements that we took down earlier. So we'll draw a circle initially for the width of the shaft, which I believe is 5 millimeters. Zoom into it. After this, we're going to have the platform that it sits on the nut, and then beyond that one we'll do the little skirt that kind of fits in the hole. So there's that 8 millimeter that's going to be sitting on a nut, and then outside of this we're going to go ahead and do one at 11 millimeters, and this will give us the little ring that fits into the hole so you don't see the nut and whatnot. One more thing we're going to do is we're going to draw a line across the whole object, kind of to have as an index. And since we know that it's a D shaft, and that is about 4 millimeters in, we're going to just drop a little line right there, and then just move the mouse up and draw a tangent. By the way, cool thing with Fusion is that when you type in a dimension in the tool, it'll kind of lock into it. So if you want to do a 3 millimeter line, you just type in 3 and hit tab, and it'll stay at 3 millimeters. Anyway, at this point we're going to go ahead and extrude this up. Now mind you, this is from the nut level, so we're going to go ahead and extrude this up 15 millimeters. I expect there to be about a 2 millimeter gap to clear the plastic, and then the button starts beyond that one. So we're going to go ahead and select the D section of the shaft, I guess, that little stopper, and extrude that up the full length, 15 millimeters. And we're going to again select it, and this time we're going to go ahead and cut and remove material. And this is for part of the shaft that's circular versus a part that has the little cut in there. So we're going to go up about 6 millimeters for this one, and that will now lock into the area that is circular in the shaft. Then the D obviously fits on top. And now we're going to go ahead and drop the little skirt area down. First we're going to move it down about 3 millimeters. And then we're going to go ahead and extend the top section up to the top. And there's the 3 millimeters. Alright, and on this one we're going to go ahead and have it, instead of having it be a unit distance, we're going to have it be to object for the extent. And we're going to lock it to the top of that inner section. And that way, if you decide to resize it later, it's not going to be two separate components and whatnot. Just kind of tidier way of doing it. So now that we have the core section, we're going to go ahead and build the rest of the knob around it. So let's go ahead and create a new sketch. And this time we'll select the top of the core area. And we'll start up with dropping a circle right on top. And we'll make this about 14 millimeters, because I think that's a pretty good width for a knob. 15, 14, yeah, 14 sounds good. And again, go back to your extrude tool and extrude this down for however long you want the button to be, or tall you want the button to be, knob. And let's go with that's too short. There we go, that sounds about right. By the way, I'm kind of winging this. The button that I initially designed was way more obsessive about it, but I'm just kind of showing you guys the procedure and how I got to it. So now with this face there, what I want to do is I want to have some way of drawing on that circular face. And, whoops, clicked on the wrong one. So I'm going to go to the sketch that we had for the top section. Remember, you can have sketches on multiple planes and multiple surfaces. So I'm going to drop a little anchor line here, right to that tangent point. And what we're going to do here is create a plane against that face that I can draw on. And you'll see why I'm doing that one. So we're going to go here and select a tangent at a point, and there's a point that we just created. And now we have a plane that is against that knob's surface. So if you create a sketch, and this time we click on that particular plane, now we are drawing right against that surface, or at least that tangent point on that surface. So we're going to go ahead and draw a rectangle right in the middle. Oh wait, I need to add a line here so I know where the middle part is. Alright, so we're going to click the top and the bottom. Remember, this is the point of contact, that tangent point, so you can click and snap to it. And we're selecting the rectangle tool that allows you to select the middle and expand out from there versus the bottom corner and top corner. So like a little indentation here for your finger. We'll do like, I don't know, 10, 11 millimeters and by about 3 millimeters. Yeah, that looks about right. Just kind of eyeballing it. Again, go with whatever you guys feel like. If you want to have them be bigger indents, smaller indents, whatever works for you guys here is nice. Alright, next thing you're going to do is we're going to go ahead and do another extrusion, except this time it's going to be a cut. We'll select both halves since we had that bisection happening, and we're going to go into the side of the knob by about 1 millimeter. And you can see the cut in red indicated there. We're going to OK that. Sorry about the emails coming in. We have a rainstorm in Southern California, so I'm getting a lot of Red Cross emails. And go ahead with the fillet tool and rotate and select the little edges so we can kind of round them out. There might be a shortcut to doing this, but this is the way I'm doing it. And kind of click on the arrow and drag until you have the edges rounded out, and this one's about nice. So we'll stick there. Again, it doesn't have to be accurate. Whatever you feel looks good or feels good on that one. And we're going to do another fillet here and kind of round out the top corner so the finger can kind of get in there. Again, feel free to eyeball it. For the outer edge, and we'll do another fillet for the inner edge. Make sure that the tangent chain is clicked on so it doesn't just try to do a fillet on that one section. It kind of all joins whatever's attached to it together. And there we go. We got ourselves a little area where your finger will kind of grip into. And here's a cool one. The pattern fill circle, or circle pattern. And on this one, it's a kind of a cool concept. You first start off with selecting the objects that you want to replicate. And as you can see, I'm selecting not only the center sections, but also the edges. Okay, drag and drop doesn't work. Shift click across all of these until you have the whole thing figured out. Then switch over to the axis option and select one of the circular areas. Now you can see that there's a shadow forming of this replicating around that axis. And you can increase the quantity to however many little ridges you want on the knob. So I think 6 looks about right. Doesn't seem too crowded or sparse. Click on OK. This will take a few seconds while it goes ahead and replicates it. And there you go. There is your little knobbies for the button. Or I keep saying button, I meant knob. We'll do a fillet on the bottom of the knob. 1 millimeter I think should be enough. Half millimeter I think that looks better. Now the top right now you have obviously a hole, which doesn't make a lot of sense. So we're going to go ahead and shift click and select all the individual components and extrude that up a few millimeters, again with the E command. And there's a little top, and again we're going to apply another fillet to kind of round this out. And let's see, right about there, that looks right. And this button seems a little bit tall with that little top hat, so we're going to hit the Q button, which is a push-pull tool. And we're going to select that top section and bring this down a millimeter or two. Let's see what looks right. Let's see, 2 millimeters, does that look right? Yeah, that looks about right to me. Maybe 1 mil, around there. Yeah, that looks about right to me. And there you go. You got yourself your knob. There's a little D-shaft area that fits in, and voila. Next comes the 3D printing. Forgot to mention this part on the previous section. Once you have your model built, what you want to do is right-click on the body, click on Save as STL, and you will see a drop-down thing. Refinement, just pick whatever makes sense. I just go with high because even at this many triangles, 50,000 is not out of control. Click on OK and save the file, and you're good to go from there. So once you have created your STL file, you want to bring that STL into whatever slicer you have for your 3D printer. We're not going to go into details on how to 3D print because there are just too many variables, and there are enough tutorials out there that kind of describe that. But just basically for this particular knob, on your print settings, make sure your fill density is 100%. Send it off to your printer. This one I'm using something called Octopi, but it's an open source Raspberry Pi installation that connects to my 7-year-old MakerBot, and it just prints from there. So we're going to print it, and you'll see a little quick video of that one. And then after that, we'll go into the post-processing, and hopefully you'll have a button about an hour, 2 hours from that point. Alright, see you in the next section. Alright, time for the time lapse with obnoxious music. Okay, that's enough. So you printed your part and you realize that it is either too tight or too loose. Well, the good part is now you have something to practice your painting on, but you have to adjust the piece again to make sure it works. But with Fusion 360, it's quite simple. Just select the face that you want to edit, hit the Q button, and this way you can push and pull that surface. So you increase it by putting in a positive value, 0.1 millimeter, 0.3 millimeter. Put a negative value if you want to have it be bigger, and go ahead and print the part again. And that's that. Alright, so now we have our 3D printed part, and we're going to do some post-processing before we get to priming and sanding. So, like most 3D prints, you're going to see some lines, and this is an old printer, so there's going to be a lot of it. But get some water, get some 400 grit sandpaper, and I wet sand because it makes the sandpaper last a lot longer. But go in there and try to remove all the little protrusions and stuff. The filler primer will be able to fill in the little holes and the little gaps between the layers, but it's not going to do anything with something protruding outward. So don't be too gingerly, just go in there, smooth things out. Also, for this particular knob, after I'm done primering, I'm going to be using the Plasti Dip spray, which should hopefully be leaving the knob with some sort of a tackier surface, which is going to be making it easier to grip. So once you're done sanding, stick it on something that you can use to paint. This one I'm using a chopstick from a takeout, and I'm going to be using that to hold it and rotate it while I'm applying the primer as well as the spray paint later on. So that's basically that. Next up, time for priming. So remember to wear some gloves, nice ventilated area, and remember to start your spray of the primer before you hit the product and spray continually through it. And be prepared to do about 5-6 layers with about 10 minutes between each layer to let it dry a little bit. So that's that. Now to sanding. So after letting the primer dry for about 2 or 3 hours, you can start sanding. I use these 3M sanding sponges. They're 800 grit, as well as normal sandpaper, which is 400 grit. As usual, I will use a wet sanding technique and get into the details pretty meticulously. With glossy paint, any kind of imperfections will very easily show. With matte paint or satin paint, it's not going to be as apparent. But be prepared to spend about 10 or 15 minutes on each one of these knobs to get a nice smooth finish. And once you're finished with the wet sanding, let the part dry, give it a few hours, and we can at this point move on to the final step, which is the plastic coat spray. So the final step is going to be applying the plastic coat spray. Just as a primer, if you want to start the spray pattern before you start spraying, go across the product the entire way and apply nice thin even coats while rotating the product. That's where the chopstick comes in very handy. For the plastic coat, I believe it's recommended that you get about 3 coats in. Right now you're seeing me apply the second coat, and after everything is dried, after about 2 hours or so, you'll be ready to put it on your radio. And there we go. There's the 868 with the old knobs, and here's the 878 with the new knobs. I would say those turned out pretty okay. Hopefully you guys will have some good luck as well. Thanks for watching.